So right now we're going to focus on energy bar charts. And energy bar charts are super similar to energy pie charts, excuse me, but we're really going to focus in on what is the system, because now energy can enter or leave the system, which is important. So we're really focused on what's the system that we're analyzing. So here I've got a projectile falls to the ground. So it's as close as it can be to the ground without touching. Great. So it's up here, not moving. See, I'm circling the system before and after. And then down here, it is moving. So if it's not moving up here and it's up high, it starts with gravitational energy. I'm going to give it 4 bars. You could give it 3 bars. It doesn't really matter. We're just saying, hey, it's pretty high up. It's got a lot of energy. So I'm just going to give it 4 bars of gravitational, saying it's pretty high up. It doesn't have any kinetic. It doesn't have any elastic. Oh, I forgot that. We're going to write the name of the system in this circle here. So that just tells us what we're looking at. All right, so then at the end here, it's going really fast and it's almost on the ground. So it doesn't have any gravitational anymore, but it does have kinetic. Now I have 4 bars of gravitational energy here. So that means over here on this side, I better have 4 bars of energy, because energy doesn't just disappear. It's still there. So since it doesn't just disappear, we need to make sure we have the same amount of energy on both sides of that equation. So 4 bars of energy to start, 4 bars of energy to end. And in this case, the energy doesn't go anywhere. There's no energy in, no energy out, because it's just gravitational to kinetic. So that's an easy one. Let's look at this one here. So my system here is the box. So the box goes from having a lot of kinetic energy to having no kinetic energy. So it goes from having 4 bars to 0 bars. Well, that energy can't just disappear. So we have to ask ourselves, where did that energy go? There's 4 bars of energy, they just left. They're not there anymore. So we show that as 4 bars of energy. 1, 2, 3, 4. And I draw an arrow going out because they're leaving. So it's just leaving the circle, going away from the box. Where did that energy go? Well, what slowed down the box? Friction slowed down the box. So it must have been going to the floor. So energy left the box and went to the floor, because the floor is what was slowing down the box. That's why it stopped. It was friction from the floor. Now, this is 4 bars, and I might even write minus 4 bars here. So 4 bars minus 4 bars equals 0 bars. In this case, 4 bars minus 0 bars equals 4 bars. So we want to make sure that the beginning adds up to the end, but maybe there's some energy transfer in or out of the system. That's called work, when an object transfers energy in and out of the system. So the box is working on the floor in this case. Let's try one more here. Right. I'm going to go number 5 here. Let's try the spring. So my system is the box, not the spring. So notice that my system is just the box. My system is not the spring. So I've got my box here to start. It says y equals 0, v equals 0. So that means it's not elevated and it's not moving. So it actually has no energy to start. But at the end, it's up in the air and it's moving. So it's got some gravitational, it's got some kinetic. Again, it doesn't really matter how many bars you give it. We're really concerned about change here. We're looking at change in energy. So I'm just going to give it 2 and 2. If you gave it 3 and 3, or even 4 and 4, that would be fine. Or even maybe 2 and 3. It doesn't matter what combination of bars you give it. I'm going to give it 2 and 2. So this was 0 bars. This is 4 bars at the end total. 1, 2, 3, 4. So that means I must have added 4 bars into my system. 1, 2, 3, 4. So I must have put 4 bars into my system, into my box, in order to get it to move and get up high. It had to put energy in, it had to come from somewhere. Where did it come from? It came from the spring. So see, I put spring there. So energy went from the spring to the box. That means the spring did work on the box in order to get it to fly up in the air. So the box starts with no energy. It gained energy from the spring. Now it's got kinetic and gravitational energy. So some of these scenarios will look similar from when we did pie charts, but when we did pie charts, we were looking at the whole big picture as a system, but here we're really isolating the system. So like in this case with number 6, we got the jumper. That doesn't include the bungee cord. So the bungee cord is going to do work on him. So we need to make sure that we keep that in mind when we're drawing him. So he starts with some gravitational positional energy, but at the end he doesn't have any gravitational position energy. Well, where did it go? Well, it went to the bungee cord. All right, so that's energy bar charts. Again, really similar to energy pie charts, but they just let us do a little bit more. They let us show that energy transfer in and out of the system.